Hey, Gary Simmons here for the Game Institute. Welcome back everybody to lesson 31 of the Dead Earth game development series. We're going to jump straight in now and continue from where we left off at the end of the last lesson. You will recall that on our camera we had this camera blood effect mono behavior, which has an on-render image function which uses our camera blood effect shader to render that quad over the render target, and currently our camera blood effect shader isn't actually a camera blood effect shader at all. It's actually a luminance shader. You can see if we look in the game window, we're just getting a black and white image. So what we're going to do first of all is we're going to open up our camera blood effect shader, and we're going to fill out the properties block so that our shader has all of the properties defined that it's going to need to have defined so that our camera blood mono behavior can feed in the various bits of information the shader is going to need. It's going to need things such as the blood texture, it's going to need the blood normal map, it's going to need the amount of blood that we want the shader to show on the screen. So the amount of blood is going to be linked directly to our health in the actual game. And also some other things as well. We're going to have a distortion float that we can send into the shader that's going to control how much the normal map is magnified to distort the image underneath the blood. It's kind of like simulating refraction. So I'm going to drill down into my Dead Earth folder, into my shaders folder, and I'm going to open up my camera blood effect shader. So here I am in my camera blood effect shader in Mono Develop, and we need to create another property straight away, and we'll call this blood, and that's going to be our blood texture. So we'll give that the label. Actually, I'll call it blood text. That's going to be the variable name, but I'll let the label in the inspector show blood texture like that, and we'll just set that to the same default white that Unity seems to use for the main texture. We're also going to want another texture which is going to be blood bump. That's our normal map or bump map. So we will call this blood normal or blood bump. I'll call it blood normal, although we're not actually going to be using it as a normal map. Like I said, we're going to be using it more to simulate how to distort the pixels of the source texture underneath where the blood is showing up on the screen. So of course our blood bump map is also a 2D texture, and apparently looking at the documentation, when you're using bump maps there is this default color, but you can just type in bump. It doesn't matter if you use it, I guess it's just the right thing to do. Okay, so we have these three textures defined, so we need to now go down into our HLSL code, and we need to make sure that we have two sampler 2Ds also declared in our shader of the same name. Blood text and another sampler 2D which I called blood bump. And we're also going to want to send in a float that's going to describe to the shader the amount of blood that we wish to show. So we'll call that, I don't know, blood amount. And I'll also call that blood amount in the inspector as well. This is going to be, should I make it a float or should I make it a range? I think I'm going to make it a range value between 0 and 1, I think. It is possible that we may want the blood amount to actually be larger than 1 going in, but I'm gonna leave it between 0 and 1 because those are sane values, and we'll set it to 0 to begin with, like so. Okay, and the other thing I'm going to have is I'm going to have another float called distortion. Now the distortion factor is going to be how much we want to essentially magnify the distortion that the bump map gives us, because if it just so happens that the normals stored in the normal map aren't very strong, then we have this additional control that can boost the distortion that the normals are going to give us. So I will call this distortion, and I will call it distortion in the actually I'll call it blood distortion. I can probably make this a range value too. I can't imagine we're going to want to be boosting the normals in the normal map any more than say 2 as a maximum. So we need to add two float variables now to our actual HLSL code, one called distortion, one called blood amount. Underneath there I will create a float. I will call this one blood amount. Remember, the names have to match exactly. And another float, distortion. I think that's all I need for now, so I'm going to save that off, go back to the editor and just check I haven't got any errors. Okay, so that's pretty much all I want to do in the shader for now. I just wanted to get the properties block defined so that I can now jump over to the camera blood effect mono behavior on our camera game object, and we can write that script now. And of course, part of that script's responsibility is going to be using the material interface to send in things such as the distortion amount, the blood texture, and the bump map or /normal map for the image effect shader. So let's open up our camera blood effect now in MonoDevelop by double clicking on it and start adding some of the fields and variables to this class so that other objects in the scene can contact the camera blood effect script and configure how the blood should look on the screen. I should probably just mention that although we haven't developed this script yet, a little bit later on, if I select our FPS controller rig, although we have the FPS controller script on it at the moment, and this script focuses on managing the motor skills of the player by communicating with the character controller, we've already covered that. We're actually going to add a higher level manager script to our FPS controller rig called the character manager. The character manager is going to be the script really that all of the other objects in the scene will communicate with when they wish to talk to the player, such as when the zombie, for example, attacks our player. If the zombie's hostile colliders are making contact with the player's collider, it's going to contact the character manager. It's going to say, I am doing damage to you, and then the character manager will calculate how much damage is being done, decrement that from the health, and then the character manager will then contact our camera blood effect script and will configure the blood amount. The character manager is going to be responsible for a load of other things as well, such as the inventory, such as when the player fires a weapon, it's the character manager that's going to actually perform the raycast and see what, if anything, has been hit in the scene and whether damage should be applied to that NPC. The character manager is also going to be responsible for managing the animation of the arms rig as well, all things that we're going to do in the future. But for now, just keep in mind that there's going to be a character manager script on our player, and that's the thing that our zombies are going to contact when they're doing damage to the player. And it's that character manager script that is going to talk to our camera blood effect script and is going to configure the variables to get the blood to show up on the screen how we want it. So before we add some variables, I just need to talk to you a little bit about how this is going to work. There's going to be a basic blood amount variable, which is describing to this onRenderImage function each frame how much blood should be on the screen. But there's also going to be an update function that is going to make that blood amount decrement with time. But there's also going to be a minimum blood amount variable, and this is going to be very closely linked to what the player's health actually is. And it's going to describe to the onRenderImage function the minimum amount that our blood effect variable should ever be allowed to fall down to. And the reason why we do this is, let's just say, for example, we have 100% health, which means our blood amount is 0 and our minimum blood amount is 0. Then let's say that the zombie comes up, attacks us, and deals 25% damage to our character. So what will happen is the minimum blood amount will be set to 0.25, mirroring the amount of damage that's been done to the player, which is like the reciprocal of the player's health. But the actual blood amount when the damage is first done will actually be quite higher than that. We might add maybe another 30 or 40% on top of that. So although the damage done to the player is 25%, we might temporarily, to make the blood effect look cool, add 60% damage. So we would set our blood amount to 0.6, and then over time the blood amount would just fall back down to 0.25, our min blood amount. And of course, as our damage gets increased, the min blood amount will always be going up. And that's how we're going to achieve that effect of when you get hit by a zombie, it looks like the screen gets splattered in blood, but then some of it will dissipate with time, and you'll just be left with little bits of blood on the screen. And how much blood you're left with is going to indicate exactly what your health is. So we're going to need two floats. We're going to need a blood amount and we're going to need a min blood amount. So I'm going to serialize both these fields so they show up in the inspector, even though I want them to be private, and we'll create some public properties for them. So it's going to be a private float called blood amount, which we'll set to 0 by default, and another private float, once again serialized, which we'll call min blood amount, which will also be set to 0 as well. And it's actually going to be our character manager that's going to set these two variables when damage is done. So what we'll do down here is we will also add some properties. I'll also put a comment up there saying inspector assigned, so I know what these are, and things that aren't inspector assigned I'll just say private. So in our properties section, we'll create a public property of type float called blood amount that has a getter that simply returns the blood amount, and a setter, of course, that sets the blood amount, and another public float property which we will call min blood. Actually, I'll call it min blood amount, which does exactly the same thing but with the corresponding min blood amount variable. Of course, also a setter as well. Min blood amount equals a value. And we're going to see how these are going to be used in a moment. Of course, what we're also going to need is we're going to need some variables defined which are also serialized to the inspector that will allow us to hook up our blood texture and our normal map. So we'll create another serialized field, of type texture 2D, and we'll call this blood texture and set it to null by default. And another serialized field, once again another texture 2D, and we'll call this blood normal map. Set that to null by default. Let me just save that off, check they're all showing up in the inspector, and in fact we might as well hook up some of those references now. So I'm going to select my camera, and then I'm going to drill down into my textures folder. I'm going to drag over my blood texture and drop that in the blood texture slot, and I'm going to drag over my blood normal and drop that in the blood normal map slot as well. I also said that we're also going to want a float variable called distortion that's going to allow us to scale up or scale back the influence of the normals fetched from the normal map and how they're used to distort the source texture that's going to be underneath where the blood is showing up. And if you don't know what that means, it will become more apparent when we start actually working on the fragment shader. So once again, I'll create that where I created the blood amount and the min blood amount. It's another serialized field, so it shows up in the inspector, so we can easily configure the blood. And it's a private float. I'll call it distortion, and we'll set that to 1 by default. So it just basically means that initially we're just going to extract the normals from the normal map in the fragment shader, and we're not going to scale them up or down in any way. We're just going to use them as they are. Now it might be that that will generate far too much distortion, but we can just slide this up and down in the inspector until the blood looks exactly how we want it to look. So let me save that off, go back to the inspector, and I'm getting an error there. So what have I done wrong? There you go, I've put a D in there, haven't I? Should be serialized field, not serialized field, and it's a good job I got that error because I also want to create some public properties there. Actually, do I? I probably don't. I don't think the distortion is something we're going to need to set from other scripts. It's something we're just going to want to configure in the actual inspector itself. So as long as it's serialized, we don't actually need to create a property. So let me save that off, go back, check I've got no errors, and there's our new distortion value there. Now this feature of our script that has the blood amount falling to the min blood amount over time is probably a feature that we should be able to turn on and off, because in this script we're just going to do a straight linear fall over time from blood amount to min blood amount. But it might be that you want to turn this feature off, and in the managing script, like say for example our character manager, you might want to control that yourself with, I don't know, some kind of curve or something like that. So we'll make this a feature that we can turn on and off in the script itself. So we'll do that by first of all creating a serialized field. It's going to be a private bool, and it's going to be called auto fade, and we'll set it to true by default. So when this is on, it means that our update function is going to decrement our blood amount down to the min blood amount. I just noticed I've spelt min blood wrong. It should be min blood, not min blood. I'm sure you saw that ages ago, right? Let me correct that. So we're also going to want another variable that's going to allow us to control the speed at which the blood amount falls down to the min blood amount. And that value that we create here is then going to be multiplied with time.delta time each frame, and that combined value will then be used as the value with which to decrement the blood amount. So we'll make this a serialized field again. It'll be a private float, and what should we call this? We will call this fade speed. Seems like a pretty good name for describing what it does. Now what should we set this to by default? The value we set here is how much is going to come off of blood amount per second, alright? So, I don't know, probably something like 0.05, quite a small value. Let me put the F on the end there. And I'm going to need to go down and create some properties for these as well, because these are things that we probably are going to want to have the ability to control from external objects and scripts. So I'll create a public float called fade speed without the underscore, and just like the ones above it, it's going to have a getter that returns the fade speed variable and a setter that sets the fade speed variable. And then we'll create a public bool property as well called, of course, auto fade. And I'm sure you know what this getter and setter is going to look like now. Returns the auto fade variable, and in the case of the setter, sets the auto fade variable like so. Save that off, just check I haven't got any errors, and no, I haven't. So what we'll do now is we'll implement, let me just zoom out a little bit, I've probably zoomed in a little bit aggressively there, so we can see all of the variables that we've added to this script on the screen at once. So what we'll do now is, above the onRenderImage function, we'll create our update function. Remember, this is one of Unity's magic functions, which will be called each frame by the Unity game engine. And what we'll do is we'll simply say if auto fade is enabled, then we will decrement from the blood amount the fade speed multiplied by time.delta time. And then we'll make sure underneath that it's never allowed to fall down below the minimum blood amount. So we'll say blood amount equals mathf, whatever is the maximum out of blood amount, and of course our min blood amount. We certainly don't want our blood amount to drop below the min blood amount, and certainly in the cases where min blood amount is 0, we don't want it to drop in below 0 either. We don't want negative numbers as our blood amount. So you can see every frame, if auto update is set to true, then we're going to take fade speed times time.delta time away from our blood amount, and of course if we didn't have this check in, it could fall into negative numbers or fall much lower than our min blood amount. So then we just say we want blood amount to be whatever is the maximum between what the blood amount currently is and the minimum blood amount. So blood amount should never be able to fall below this amount. Okay, so that's pretty much that. Now we want to go down into the onRender image function, and we want to add the code that's going to send all of this data into the shader, and in particular our textures, of course. So in our onRender image function, we make sure that we've created the material, we make sure we've got a shader, and if we haven't got a shader or material, we return. So we should put it here above the graphics blip function. So I'll put a comment in there saying send data into shader. And of course, in order to do that, we just use the methods of the material class, because the material class has functions such as set texture or set float. So we'll just use those. So let's send our textures in first of all. So we'll say material.setTexture, and we have to send the string in, which is the name of the property of our texture, which is, I think we called it blood text, didn't we? Let me just go back to my shader, make sure we definitely called it blood text. Yeah, it's this variable name here, not the inspected display name, alright guys? So we've got blood text and blood bump. And then we send in the actual texture, which is of course our blood texture that we have already hooked up in the inspector here, look. Yes, and we need to send in the blood normal map as well. In fact, I should probably just make sure that we only do that if the blood text isn't null. Like so, and then we'll do the same for the bump map as well. So we'll say if blood normal map doesn't equal null, well then we use the materials set texture function again. This time of course the property name is blood bump in our shader, and we send in our blood normal map like so. So at this point now the shader that is attached to our material has access to the blood texture and the blood bump, but we've got some other things to send in as well. We also need to send in the distortion, and we also need to send in what the current blood amount should be. So distortion and blood amount are both floats. So we will say material.setFloat. Go back to our shader, just remind myself what I called distortion, just distortion with an underscore like so. And pass in our distortion variable. And then material set float again. This time we're going to set the value for, what did I call it? I called it blood amount. Remember, main text is automatically populated with the source texture from the blit function. So blood amount, and of course for that we send in our variable blood amount. And I'll put a comment in there saying perform image effect just above the blit function. And I think that might actually be our script done for now. It's very basic. We might want to come back and do a few more complicated things later on, but I think that's enough to get us up and running with our blood effect. Let me just go back, check I haven't got any errors, which I haven't, which is always a surprise. So now what we're going to do, now that we know that our shader is going to have all of its properties populated by the onRender image function via the material class, now we can open up our image effect script and we can start to really author this puppy to use all of these variables to create our blood overlay. So this all happens in the fragment shader, okay? We don't have to alter the default vertex shader one little bit. Oh no, that's fine just as it is. Everything happens in here, inside the fragment shader. Okay then, so the first thing I'm going to do is get rid of that line that calculates the luminance of the source texture. Remember, main text is our source texture. That's the texture that has been provided to our shader by Unity and contains the current render of the scene. So I'm going to change the name of the color sample from that texture from coal to source coal. Okay, so I know that's the source texture, and just like C++ or C#, we can put comments in our code using 2 forward slashes. So I'll put in here sample the source texture. We're going to be ultimately calculating a color to output from the fragment shader, which I'll call output. So just to stop us getting an error while we're testing, because you can see I'm creating a fixed for here using the loom variable, which is no longer there, I will say return output, which is going to be a color that I'll create just above it. And for now, I'll just copy into that output variable what source color is, and we'll obviously do something more interesting with that in just a moment. So let me just save that off. So we've sampled the source color. We're currently just copying the source color into our output variable and returning that. Of course, we also need to sample the blood texture using the same UV coordinate that's been interpolated from the vertices, so that we know for the current source pixel that we're processing what the corresponding pixel in the blood texture should look like. So we're going to create another fixed for. I'm going to call this blood col for blood color, and of course we're going to use the HLSL text 2D function to sample the texture again. This time though, instead of sampling main text, we're going to sample blood text, which we saw a moment ago is fed into this shader via the onRenderImage function of our camera blood effects script. And of course we want to use the same UV coordinates when sampling the blood texture as well, because these two pixels are supposed to correspond to one another. Okay, we're trying to see what the corresponding pixel in the blood texture should look like so that we can blend it to some degree with the corresponding pixel in the source texture. Okay, so a very naive implementation, of course, might be to just return a linear interpolation between the source color and the blood color based on the blood color's alpha channel. So let's see what that would look like. We'll say output equals, and we'll use the HLSL's lerp function to do a linear interpolation between two 4D vectors, or in this case 4D colors, and we'll interpolate between source color and blood color, and the interpolation factor will of course be the blood color's alpha value. Now obviously this isn't going to work at all right, but we are at least going to get to see the blood show up on the screen and blend over our image buffer. Hey, there you go. But of course the problem with just using the alpha value that's in the blood texture is it doesn't factor in our blood amount. So here I am sliding my blood amount variable in my camera blood effect mono behavior on my camera game object, and it's not changing a goddamn thing. So what we need to do is we need to change this calculation so we don't just use the blood color's alpha value unmodified, or otherwise it will always be exactly how the alpha channel is authored in the texture. We want to modify it in some way. So let's try just multiplying it with the blood amount. So we'll say blood color dot A, and we'll multiply that blood amount. It's a capital B, isn't it? Save that off. Go back. So we can see it kind of works now. If we move blood amount down to 0, the blood disappears. If we move it up to 1 or just over 1, we can see that the blood fades in and out. But it's not what we want, is it? Because we don't just want that image in the blood texture to fade in and out. We wanted the blood with stronger alpha values to show up before the blood with smaller alpha values. So let's make a modification. So instead of simply multiplying the alpha value by the blood amount, what we need to do is add a signed value onto the blood amount that can be in the -1 to +1 range, so that the calculation that we perform may either boost the value that's in the alpha value up to 1 or clamp it down to 0. So the best way to explain this is just to, if I show you the calculation, then we'll talk about it afterwards. So I'm going to say bloodcol.a equals bloodcol.a, and then I'm going to add on to bloodcolor.a, and I'll put this in parentheses just because, although I don't have to, it makes it a bit easier to explain. Our blood amount multiplied by 2 minus 1. Okay, so you can see that this calculation here takes our blood amount in the 0 to 1 range and maps it into a -1 to +1 range number. And then by adding that onto our alpha value, we can actually subtract a quantity from it and not just multiply it or add to it. So in the case where blood amount is 0.5, 0.5 multiplied by 2 equals 1 minus 1 equals 0. So this all equates to 0. So at blood amount equals 0.5, the alpha values as authored in the texture remain as they are. However, in our blood effect, we want it to behave a little differently. For example, when the blood amount gets quite high up, we want some of these pixels here, which don't have any blood on them at all. In other words, they have an alpha value of 0. We want those to also become red so that we can ramp it right up and eventually make all the screen red. And this calculation does that because let's imagine, for example, we have an alpha value in our blood texture of 0, but our blood amount is 1. 1 times 2 is 2, subtracted from 1 equals 1. So we're actually setting at its most extreme any alpha values in our alpha texture that were 0 to 1. that will make the whole screen go red. However, there's also another benefit. We said that we wanted some of the pixels in the alpha map that have lesser values. We don't want them to fade in. We want them to come in only when the damage gets so much. So as our blood amount starts to climb into higher numbers, we start to see some of the duller alpha values show through. And as the blood increases, we also want those to get brighter as well. And that's already implied in this calculation. For example, let's assume that this little bit of blood here that I'm moving my mouse over, let's assume that this has an alpha value of 0.25. If we also had a blood amount of 0.25, obviously we would see this to some degree. It would be about half the intensity it is now, but it would show up. But we don't really want it to show up right away. So with this calculation, let's assume that we have an alpha value of 0.25. Okay, that's the intensity of the alpha value of this region of blood here. And let's assume that we have a blood amount of 0.25 as well. So we've got, a quarter the amount of blood that we could possibly have on the screen. Well, 0.25 times 2 is of course 0.5. Minus 1 is minus 0.5. Now that value that we extracted that was 0.25 has 0.5 subtracted from it, pushing it into negative numbers. Now obviously we don't want the values in negative numbers, we just want them to be clamped to 0 in that case, so they have no effect. So what we'll do is wrap this whole calculation in the HLSL language's saturate function, which is basically a 0 to 1 clamp. Okay, so if the result of this calculation is larger than 1, it will be clamped to 1. If it's smaller than 0, it will be clamped to 0. So if we look at it now, because blood amount is 1, we're seeing that the whole blood texture is showing through. Even on pixels where it was originally 0 in the alpha channel, so they're still getting boosted up to 1. You can see if we move it down to something like, I don't know, like 0.4 or something, here you can see that these pixels and some of these pixels here have been sort of clipped away from the blood texture, so they're not being rendered over the top, but we're still getting some nice vibrant blood splats in other places. And as we start to turn it down, we start to see more blood disappear. And if we see something like that, we can still see now we just have some little splats on the screen. Now this isn't the finished result, okay, so it's going to look a lot better than this, but you get the idea. We've now got a value that can, even boost up pixels in the blood texture that had an alpha value of 0. So we'd never want to go up to that, obviously, but we'd probably want to go up to something like that, Okay, so quite a long way towards creating the effect that we want. Okay, so the problem that we have at the moment with this effect is that once we extract the blood color from the blood texture, we are just using the alpha value of that color to do a loop between the source color and the blood color, which basically means once we really boost up the alpha values, or in the cases where the alpha values are very dominant in the alpha channel, it means wherever the blood is at full intensity, the color on the screen is going to be completely the color of the blood without any of the source color blended in. And we can see this because if I ramp up the blood amount to 1, it's a fully opaque effect. We can't see any of the scene showing through. And of course this is supposed to be blood, which is supposed to look like red liquid, so we never want the blood to be fully opaque. So what we need to do is we need to now calculate what we want the actual blood color to be. So where the blood is showing up, we wish to sample the blood color from the blood texture and then blend it to some degree with the source texture that is already there underneath it. So we'll create a new color for that, which I'll call overlay. Once again, it's just another fixed for. I will call it overlay col, and we could start by simply multiplying the two colors together, right? Source col times blood col, like so. And then we could, instead of interpolating to blood col as the final output, we would actually interpolate between the unmodified picture that's currently in our source texture and this new overlay color that is a blend of the blood and the source color. And of course the strength at which this overlay color is used versus the unmodified color in the source texture is dependent on how strong the alpha channel is of the pixel we've sampled from the blood texture and modified here. So we would interpolate to overlay color instead, and you'll see that the blood's going to go very, very dark now. But you can see that although it's gone very, very dark, it does look quite nice dark, to be fair. Although it's gone very, very dark, you can see that even when we put it all the way up. Hopefully you can see this in the video, because I know sometimes when we compress the videos for upload, the things can get much darker than they appear here, but you can see that it's still transparent. I can still see the scene behind the camera. But of course, I think that the straight multiply between the source color and the blood color to create the overlay color is darkening the color too much. And of course, we always know that happens when we modulate two colors together, because unless the colors are bright white, their components are in the 0 to 1 range. So obviously multiplying any fractional value by any other fractional value is going to diminish that value even more so. And one way that you can get around this is just do what's called a 2 times modulate. Let's see what that looks like. There's also a 3 and a 4 times modulate we can do if it's not how we want it to be. So let's try that. Yeah, that might be okay. Of course, we could go right up and do a 4 times modulate if we wanted to. We want to kind of over brighten it at this stage, because when we start bringing the normal map in, that may actually darken it down again. So yeah, I think for now I'll stay with a 2 times modulate. Okay, so we've got the overlay color calculated. The overlay color, remember, contains the color that we wish to display when blood is on the screen, and how strong we wish to blend that with the source color is obviously controlled by this lerp and the alpha value of our blood pixel. So what we want to do now is implement a little bit more control so that we can control how much of the source color is in the overlay color and how much of the blood color is in the overlay color, because that will allow us to make the blood more or less transparent. So we'll do that by saying overlay col equals lerp, and then we'll lerp between the source color, the overlay color, and for now we'll just use a lerp value of 0.5. So if it doesn't look quite right, or we want the scene underneath to show through more, we can just come and tweak this value. And in fact, you could even actually implement this as a shader parameter and expose it in the inspector of your camera blood effects script, but I'm not going to do that. I'm just going to hard code it. Alright guys, so as you can see, that's changed how it looks quite dramatically. We're seeing a lot more of the scene showing through now. So obviously it's totally up to you how you want to do it. So if I wanted to make this 0.25, well then the blood wouldn't show up that much at all. We'd see much more of the scene showing through. It would just very lightly darken it. But if we want to go all the way up to say 0.85, where we're using much more of the overlay color, well, that's not actually that bad, is it? Maybe we'll stay with that. Okay, so just to recap everything, we sample the color from the source texture, we sample the color from the blood texture, and then with the alpha value sampled from the blood texture, we then perform this addition of a assigned value in the -1 to +1 range to, based on the value of the blood amount, force some of the lesser alpha values to 0 where they may not be, and in the case where we've got a big blood amount, to actually boost some of the low alpha values so that they become much stronger as the blood amount increases. So once we have this alpha value calculated and we have the two colors that need to be blended together, we blend them together doing a 2 times modulate color blending operation. We say overlay color equals source color times blood color, and then we multiply by 2 to boost the brightness of that overlay color. But we want a little bit more control as to how much of the source color shows through. So I do this final lerp here where I say overlay color equals lerp, and then we lerp again between source color and overlay color, allowing us to dilute the overlay color versus the source color. Now we have the final overlay color with the transparency or opacity that we want. We then output the final color as a lerp between the original source color in the frame buffer and our new overlay color, and we use the alpha value as the lerp factor for where the blood should show up and how strongly it should show up, and then we return that from our fragment shader. Of course, we haven't added the bump map stuff yet, and that's going to make this look a heck of a lot better, let me tell you. So, but you can see we've got it basically working how we want. Like that, a little bit of blood shows up, and as the blood amount increases, we start to see even some of the stuff in the non-bloody area start to tint red. And we push it all the way up. Now everything's red, and we can see some of the texture there of our original blood texture. And we have the ability, like I said, to change how much of the underlying scene shows through the blood. You can see I've just set it to a 0.5 interpolation there, and much more of the scene shows through, and the blood doesn't darken it quite so much. But like I said, I'm going to put that to 0.75 for now. Seems like a good value. Yeah. Okay. So we're also sending a normal map in to our shader, and we know what normal maps are. Okay, each pixel in the normal map basically represents a vector. That vector is essentially a tangent space vector. So it basically means that for our quad, the z component represents the dominance at which it's pointing straight at us. The x component represents how much the vector is deviating horizontally, and the y component how much the vector is deviating vertically. So what we can do is we can take the x and y components from the vector, which once again describe how deviant from the normal of the surface that vector is, and we could just use these to modify the UV coordinate that we're going to use to sample the source texture. This will essentially create some distortion, as we are on purpose essentially sampling the source texture incorrectly in places where we have a strong alpha value, where there is blood, and that will simulate in a way a type of refraction. Okay, where the blood is, the source texture underneath will be misaligned slightly from the scene that isn't being covered by blood. So I'm going to move this underneath where we calculate our blood alpha channel, because we're going to use the blood alpha channel and the bump map to actually sample this source color from our source texture. So normally, in order to extract a normal from a normal map, what we would do is we would create either a float 3 or a half 3. I'll create a half 3 here, and I'll call it bump. And what we would do, or what you would think we would do, is we would just do text 2D, pass in our bump text as the texture we wish to sample, and of course pass in once again our UV coordinate. Okay. Now this isn't something that you want to do, and you'll probably get erroneous results. The problem is, depending on the platform that you're compiling for or you're running the application on, the normals can be encoded in the bump map in a different way. So in order to get around this, so we get a consistent vector back, Unity has provided us, via that Unity CG Inc. include file, a really handy little function called unpack normal. So if we wrap our texture 2D operations in an unpack normal function call, then the data that text2D returns, the unpack normal function will actually make sure that it's formatted in a vector format that we would expect, where X, Y, and Z represent the components that we would expect them to represent. However, in this particular case, all right, I'm not really interested in what the Z component of the normal is. I'm only interested in using the X and Y to essentially offset our UV coordinate horizontally or vertically respectively. So what I'm going to do is I'm going to make this a half 2, and then with the vector that unpack normal returns to me, I'm going to tell the compiler that I only want the X and Y components that will be stored in this 2D vector called bump. So what we're going to do now is we're going to just use this 2D vector to offset our texture coordinates. Okay, so we're going to add on to our UV coordinates the displacement horizontally and vertically described by the normal in our normal map. Now, of course, we don't want this bump value to affect the UV coordinate lookups of pixels that don't have any blood on them. We only want distortion where blood is. So we will multiply our bump vector with our blood color's alpha value. So that if the alpha value is 0, if there's no blood in this area, then bump will be multiplied by 0, and we won't be adding anything to our UV coordinate. But of course, where the alpha value of our blood color is non-zero, then we will be scaling that bump offset by some degree. So the stronger our alpha value, the more offset we will get and the more distortion in the text. It's very subtle. It won't be that easy to see the distortion, but it really is what makes it look like it's not just blood painted on a flat image. And then finally, we'll multiply that again by our distortion factor, which will allow us some control over exactly how much distortion we do actually want. And I think that is our final fragment shader. So let's save that off and see the catalogue of errors that I've got. There you go, got some errors on line 58. What have I done? Oh, it's not called bump text, is it? It's called blood bump. Not happy with that name. I like my textures to have text on the end, but I'll go with it for now. Okay, wow. Well, that looks quite a bit different, doesn't it? That's because our distortion is like mega. You can see, look, because of the distortion, because I've got the blood amount way up, you can see as I increase the distortion, you can actually see the scene underneath actually moving. That's that displacement that we're doing. But of course, we don't want anywhere near that much distortion. So I think the distortion should probably be somewhere, maybe that amount, 0.2 or something like that. And we'll just turn the blood amount down. So you can see now this is starting to look a lot better. Let's full screen this. Yeah, it's looking pretty cool, isn't it? Now, interestingly enough, sometimes you can get a better result using a lower resolution normal map, because sometimes this can just look a little bit too detailed. And so let's try lowering the resolution of the normal map and see what happens. It's currently set at 2048. Of course, one of the other things you could do as well is turn the noisiness of the normal map right down if you're getting too much noise. You know, arguably we probably were there. I think that looks a bit better. But let's turn the normal map down to something really small, like a 512 by 512 texture. Sometimes that can actually look a little bit better. It can make it look a little more liquid. What am I looking for here? Oh, my camera. So you can see, you know, as it comes on the screen, sometimes I don't know, I think that looks does that look better? I think it does. And, you know, if you can get away with using a 512 by 512 normal map versus the one I was using, which was actually set to 2048 originally. Let's try 1024. Well, it's up to you guys. I mean, this is just preference at the end of the day, isn't it? I mean, I actually prefer the normal map looking a little bit more blurred. I think it just creates more of a watery effect. So I'm going to go back and put my normal map down to 512. And I'm also going to, I think, maybe just see what it looks like with the actual blood texture. I've got a massive blood texture at the moment. It's 2048. Let's put it down to say something like 512, see what that looks like. I mean, it hardly makes any difference, does it? I mean, it might look a bit different when I turn the blood amount right up. Let's be honest, it doesn't, does it? So, there you go. Looking pretty good, isn't it? And just to remind you one more time, if we give it a higher res bump map again, looks like that. I suppose that does look better, doesn't it? Yeah, maybe I'll stay with a higher resolution. Okay, I'm going to settle on 1024. I'm going to settle on that one. And you can also see that our min blood amount works here. If I set min blood amount up to say 39, you can see that even if I put blood amount down to 0, it gets clamped to 39. So if our blood is animating down to 0, you know, but our health is 39, that's what it would look like. We'd still see we've got some blood on the screen and we've got some problems. So now that our image effect is complete, we need to actually do something useful with it. What we need to do is when our zombie attacks the player, at the moment we're just having some text being output from the zombie's damage trigger saying, hey, the player's been hit. What we need to do is we need to have those zombie damage trigger scripts contact our FPS controller rig, tell it that it's taking damage, and then we need the FPS controller rig to adjust its health internally, and then contact the camera blood effect script to configure the blood amount and the min blood amount. Now what I'm going to do in preparation for that is I'm going to set all of these values in the camera blood effect script back to their defaults or starting values. So we're going to set min blood amount down to 0 and blood amount down to 0 as well. And I'm going to leave distortion at 0.21. I quite like that, but of course you can configure it however you want in your game. And as with all my other lessons, all of the code that I input in this lesson is available for download. It's in the zip file that accompanies this lesson. And you can find all of the zip files alternatively in the resources section of the Dead Earth channel. Okay, so just to recap before we continue, a couple of lessons ago we were working on our zombie attack system, and you will recall that if I open up Omni Zombie Jill's hierarchy and drill down to a left hand, each of the zombie's weapon limbs, which on our zombie was the left hand, the right hand and the mouth, had its own sphere collider that was configured as a trigger and assigned to the AI trigger layer, but it also had this AI damage trigger script. The AI damage trigger script is the script that has its on trigger stay function called when the zombie is attacking the player and Unity detects that this trigger is penetrating our FPS controller's collider. Let's just open up the AI damage trigger script to remind ourselves what it looks like. Hopefully you will remember that one of the key variables in our AI damage trigger script is this parameter string here, which describes the corresponding variable in OmniZombieJill's animator, we need to be listening out for to see when this trigger becomes hostile and should be doing damage to the player. So just to recap, if I go back to the editor, you can see that we have assigned the parameter string left hand to the AI damage trigger script that is on the left hand game object. And if we call up OmniZombieJill's animator, you can see there's also a parameter in there called left hand. And you will remember that we set up animation curves on each of these attack animations. So only at the point when the left hand should be inflicting damage in the middle of an attack does that animation curve take that left hand parameter up from 0 to 1. So only when this is 1 or greater than 0.9, I think was the test we did, do we actually apply damage. So if we go back to the script again, you can see this happening in the onTriggerStay function. You can see that when a collision happens with this trigger, if it's not the player that this trigger has collided with, then we ignore it. But even if it is the player, we then check to see if the matching parameter in the animator is set close to 1, larger than 0.9. Because even if it is the player, but this parameter is set to 0, then it means essentially the player has probably just brushed up against one of these triggers and it isn't actually the zombie that's in the middle of attacking us. And of course, when that was the case, we just put some temp code in here for the time being that just moved the blood particle system's position to the position of impact, rotated it around so it faced in the same direction as the camera, and then we just spurt out some blood particles. But in the actual game, we'll probably do something a little bit better to make sure that the blood is always seen. But all we did with respect to the player being damaged is we just output this line of text to the console window saying player being damaged. But player isn't being damaged at all. We need to replace this with some code now that's going to actually contact our FPS controller rig, tell it that we're taking damage, and then that script on our FPS controller rig will contact the camera blood effect and will configure the blood to manifest that damage visually. So if I go back to the editor now and select our FPS controller rig, you will recall that I think it was in the last lesson I mentioned that we're going to create a higher level manager script called the character manager that is going to live on our FPS controller rig and is going to manage all manner of things, from things such as the animated arms of the player, the inventory system, and things like that. It's the character manager that we're going to want to contact via our zombies' hostile triggers, because it's the character manager that is going to manage the health and talk to the camera blood image effect. Now, in the actual game, the health will actually be a property of the inventory. But as we haven't implemented our inventory system yet, and the inventory system is going to be quite a task, let me tell you, that's a big part of the game that we're going to dedicate many lessons to. What we'll do for now is we'll just make the health property a member variable of the character manager class. So let's drill down into our scripts folder, into our FPS controller folder, and let's create a new C# script and call that character manager. Like so, and then with the FPS controller rig selected, let's drag our character manager onto that game object. Now Unity by default puts the script at the bottom of the script stack. I don't like that, even though it doesn't matter. I like to move it up so it's with the rest of my other scripts. I don't like it being separated and like underneath things such as audio sources. So I've moved it up so it's right next to my FPS controller script and our character controller component. Okay, so how is this AI damage trigger script going to be able to talk to the character manager that's on our FPS controller rig? Yep, we could make the character manager a singleton, or we could register it as a variable with the game scene manager and have a property that allows us to get that. But I want to be a little bit more flexible than that, because although I'm developing initially a single player game, doesn't mean that down the line I might not want to change this into a multiplayer arena type game. And when that's the case, I don't want to have too much code that is absolutely dependent on the fact that there is only ever going to be one character manager or one player controller in the scene. So what I'm going to do is I'm going to do something very similar to what we did with our AI state machines for our zombies. If I call up our game scene manager, you will remember that we created a dictionary that took an integer as a key that could be the instance ID of any collider, and as its value stored a reference to an AI state machine. The reason we did this was because our zombies have lots of different colliders on them, and there'll also be a lot more once we start adding body parts to our zombie to facilitate ragdoll functionality. Therefore, at any point throughout the game, any other object somewhere in our world might detect that it's hit a collider that belongs to a zombie. and it may need to notify the AI state machine belonging to that zombie that it's either entered a trigger or it's heard a sound effect or whatever, just anything we can think of. The idea here is that we've been given a collider of a zombie and we need to get access to its state machine efficiently. So what we did in the start function of our state machine is we simply got the collider and we registered it along with the state machine with the game scene manager. And the nice thing about this is even if we have one state machine, but we have 20 different colliders on that state machine, we can just have 20 entries in this dictionary that all map to the same state machine, but all have instance IDs of different colliders. And that's fine. That's how this is supposed to work. And you'll also remember that we have this register AI state machine function, which is the function that is called by our state machine in its start function to register its collider's ID and its state machine with the game scene manager. And we also have this get AI state machine function, which can be called anywhere in our code if during a collision or trigger interaction we find we have a collider with an instance ID that belongs to an AI state machine and we wish to get a reference to that AI state machine to give the zombie some further direction. So we're going to do the same thing with our character manager, but I'm not just going to create a dictionary here that registers the character manager with its instance ID. What I'm going to do instead is create a utility class called player info, which is going to store a lot more information, pretty much anything we might ever want to know anywhere in our game about the character. So we could store things like a reference to its character manager, a reference to its camera, a reference to its melee trigger, a reference to its FPS controller script, things like that. So that if we register an object like that with the game scene manager, then whenever any object anywhere interacts with our character's controller, we can simply just get all of the information that we want about the player in one shot. So I'm going to do that first of all. I'm going to go up here and I'm going to create that new player info class. And you can see I'm creating it at the top of the game scene manager script. So it's going to be a public class of type player info. So what are we going to want to store? Well, we're going to want to store initially a reference to its character controller in case we need to talk to that. Remember, that's really just a special type of collider. So we'll create a public collider, call that collider, set it to null. We'll create another public variable, this time of type character manager. That's the script we've just added to our FPS controller rig. Doesn't yet do anything yet. So we'll call that character manager, set that to null. We may also want to store a reference to the player's camera, so why not do that? And we may also want to store a reference to our FPS controller rig's melee trigger. So that was a capsule collider, wasn't it? Let me just go back to our melee zone trigger. Yes, it was a capsule collider, so we'll store a reference to that too. And when we create our character manager start function in a minute, the character manager start function is going to allocate a new player info object. It's going to collect all of this information, store it in the player info object, and then it's going to register it with the game scene manager. Now, this is a ongoing task. Okay, so the player info class here will eventually hold a lot more information than just what we have here. But some of the things it's going to store, we just haven't even invented yet. And the nice thing about storing the player info is obviously because we're registering the player info and not the individual components, it means that as we add more information to the player info class, we don't have to add any more registration functions or any more dictionaries. So that's pretty cool. So let's create the dictionary now in our game scene manager that's going to facilitate the storage of these player info objects. Like in Dead Earth, of course, there will only ever be one player info because it's not a multiplayer game. But at least if we decide to take it multiplayer later on, that's one of the things that I won't have to worry about. And but I won't have caught them all, obviously. This isn't multiplayer proof by any stretch of the imagination. So it's a dictionary that stores an integer as a key and a player info object as its value. And we'll call this player infos. So we say new dictionary int comma player info, like so. So that's our dictionary. So now all we need to do is we need to create two functions to register and fetch, just like we did with our register AI state machine and our get AI state machine. So let's just duplicate those puppies completely. Why not? Yeah, I know whenever I do this, I'm going to be leaving commented code that isn't updated for the rest of the application's life. So we'll call this register player info. I'm going to try and remember to update the comments now. Actually, I won't update the comments now. I'll update the code now. Then I'll pause the video, update the comments. All right, because you don't want to see me updating the comments, do you? And that'd be boring. So we'll say register player info. And of course, we need to change that second parameter to type player info. So inside you can see it's basically saying if we don't have the key that's been passed already in our player info dictionary, then we're going to store it. But I need to update this code here as well, obviously. So player infos equals player info, like so. And then we're going to go down and we're also going to change the get AI state machine to get player info function. And obviously that won't return an AI state machine, it will return an object reference of type player info. And inside we'll create a local variable of type player info, which I'll just call info. Then from the player info dictionary, we will try and get a value with the key that was passed into our info local variable. I call it Ingo. And if we are able to find a matching player info in our dictionary, then we'll just return it. Otherwise we return null. And what I'm going to do now is I'm just going to pause the video and I'm going to update the comments to these two puppies, all right, these two bad boys. Okay, job done. So what we want to do now is we want to go over to our character manager script and we want to create the start function that is going to allocate an object of this type and fetch all of that information and register it with the game scene manager. So I'm going to go back to the editor. I'm going to open up the, what did I say I wanted to open up? Oh, the character manager script that's on our FPS controller rig. And we're going to need to create some variables here. So let's create some private members that we can cache references to in the start function. So we're going to want to store a reference to the collider of our FPS controller rig. We're probably also going to want to store a reference to our FPS controller script at some point so that our character manager can give that instructions or limit it from going in certain directions. We're probably also going to want to store a reference to our character controller as well. Just to remind you guys, obviously we've got quite a few scripts stacking up on this now, so just so you're not confused, obviously we have the character manager, which is the thing we're currently developing. We then have the character controller, which is the Unity component that basically manages the collision of our object in the world and how it slides up hills and things like that. And then we have the FPS controller script which we wrote, which is the thing that talks to the character controller, and it's essentially the motor of the FPS controller rig. It's what controls our speed, whether we're walking, whether we're running, and other things as well, such as whether we're falling and what our head bob should look like. So we want to store references to all of those in case we need them. Now we're probably also going to want to store a reference to our melee trigger at some point, which is just a capsule collider down there. So I think what I'll do with that is, rather than search the hierarchy for a capsule collider, I'll make that an inspector assigned variable and we can just drag it over. And I think I'll do the same too with our camera blood effect script. So up here I will put some inspector assigned variables. They'll be private, but they'll be serialized, so we can assign them via the inspector. And I think the first one will be a capsule collider that will store our melee trigger in. And like I said, we'll hook all of these up in the start function in a minute. And we're also going to want to cache a reference to our camera blood effect script, because it's going to be this character manager that's going to talk to the camera blood effect script and configure it based on the damage that it's taking. Okay, so what I'm going to do now is I'm going to pop down into the start function. At the top of the start function, we're going to hook up all of these references. Now obviously with the inspector assigned references, we need to do that in the editor, but with these we can just get them straight off the object that this script is currently on. So we can say collider equals get component collider, FPS controller equals get component FPS controller, and what else? Character controller. Do simple get components with these because all of these components are on the same object as this script, the character manager. So get component character manager, like so. So before we forget, let's save that off. Let's go back to the editor. Oh, I've got an error. What have I done here? Oh, I did character manager, not character controller. It's not good, is it? Okay, save that off. Go back. And what we'll do is we'll hook up these references in the character manager script as well. So for the melee trigger, we will just drag over our melee zone trigger object and drop it in there. And of course, Unity is clever enough to know that even though we just dragged over the game object, it was a capsule collider that it was looking for. And what else did we want to store in it? Oh, the camera blood effect. So let's just drag over our FPS camera and that should find it. Actually, we probably want to store the camera as well, don't we? Yeah, let's make that a serialized field as well, the actual camera itself. Like some of these things you're not going to see us using right away, but a little down the road we are going to be needing all of these things. So we'll create a serialized field called camera as well. We'll go back to the editor and we'll hook that up as well. Yep, there it is, by just dragging over our camera. So by the time our start function executes, our character manager will have access to the capsule collider on our melee trigger. It will have access to our camera blood effect script. It will have access to our actual camera, and plus all of those components that it also fetched off of its own game object: the collider, the FPS controller, and the character controller. So what we're also going to want to store a reference to for ease is we're going to want to store a reference to the game scene manager, aren't we? Because we're going to need to talk to that to register ourselves with it. So we'll just create a variable there called game scene manager. And because the game scene manager is a singleton, we'll just say in our start function, game scene manager equals game scene manager.instance. Okay, so the next thing we're going to do is we're going to allocate a new player info object, fill in all the data of that object, and then register it with the game scene manager. So let's first of all check we have a valid reference to a game scene manager, that we haven't forgot to put it in the scene. Player info, we'll allocate a new local object of type player info, which I'll call info, equals new player info, like so. And then what we want to do is just fill in all the members of the player info. So info.camera equals camera, info.character manager equals this. Remember, this is the character manager script we're writing here. What else we got in there? Oh, collider equals, and of course we've already cached the collider, so we'll copy that over to info dot melee trigger was the last one, which was a capsule collider. So we'll just copy over the reference we've got to our melee trigger. And now with all that data filled out, we can then say game scene manager register player info. We send in our info object that we've just allocated as the second parameter. And as the first parameter, we send in the instance ID of our collider. So collider.get instance ID, like so. So now all of this player info is registered with our main FPS character rig collider, so that those individual scripts now on our zombies' hostile body parts can, when they detect that an interaction has happened, they can just contact the game scene manager, which is a singleton, and they can say, can you please give me all of the player information that is linked to a collider with this ID. Okay, so what we'll do is we will go back to our AI damage trigger script now, and we'll delete that line of code that says player being damaged, and we'll do something a heck of a lot more worthwhile. We will say, did we store a reference to the game scene manager in here? No, we didn't, so we should probably do that. So let's create a new private variable now of type game scene manager, like so, and we'll hook this up in the start function as well. All right, guys. Of course, you don't really need to do this because you could just, use the singleton property, but I like to eliminate any kind of overhead I can, and even a property is essentially equivalent to a function call. So we will say game scene manager equals game scene manager dot instance, and then down in our on trigger stay function we will say if game scene manager is not null, well then we will try and get the player info that matches this collider's ID. So we will say player info equals game scene manager dot, and then of course we've got that get player info function that we just implemented, and for that we just pass in the collider that was passed in to this function. We pass in its instance ID, so collider dot get instance ID. And if this is of course a collider that belongs to an FPS character controller rig, then that's going to return a valid player info, but we should just check anyway. Let's just check info isn't null. So if info doesn't equal null, and in this particular case what we want is the character manager field of the info, we need to make sure that's not null as well. So we'll do this check here. We'll say if info doesn't equal null, and if info dot character manager doesn't equal null. And then in here, what we need to do is contact the character manager and tell it that we're taking damage so that the character manager can decrement the health, and contact the camera blood effect and put some blood on the screen. So we'll call a function of the character manager called take damage. Now, we haven't implemented a take damage function yet in the character manager. We'll do that in a moment, but for now we'll just put in the code that calls it here. So we will say info.character manager take damage, and the take damage will actually just take in the amount of damage I think that should be done. So I don't even know what that should be, because obviously this could be called several times. It's all been done in the physics update, so let's just put 1 in there for now, see what that looks like. We may actually come back in a minute and actually create another property of the AI damage trigger script called damage amount, so that we have precise control over how much damage is done for every fixed update that the zombies collider is in contact. And what's cool about that is it will allow us to configure it differently in the inspector. In fact, I am going to do that right now, okay? I've decided it's too much of a good idea to pass, so I'm going to create a new member of our AI damage trigger script. It's going to be a float. I'm not quite sure really what sort of scale these values should be in yet, and I'll just call it damage amount. All right, and this is the amount of damage that should be done for each fixed update, which remember executes 50 times per second, that this collider is in contact with our player's character controller. So we're probably going to want things such as the hands to have quite a large one, because they're only going to very briefly be in contact with the player's collider. But we'll probably want the mouth one to have a much smaller damage amount, because it may be in constant contact with it, and if it's being called 50 times a second to apply that damage, the player could go from perfectly healthy to utterly dead within a split second. So we'll set damage amount to, I don't know, 0.1 to begin with. I've got no idea what value that should be. We'll have to check it. And then down in this function, that is the amount that we will actually pass in to the take damage function. So let's just go back to the editor, check we haven't got any errors. Well, of course we've got errors. What am I talking about? We haven't implemented the take damage function yet in our character manager. So let's go back to the character manager now, and let's temporarily put in an additional property that's inspector assigned, so that we can see the health dropping in the inspector, and we'll call it health. And like I said, in the actual game, when we develop our inventory system, it's actually going to be the inventory system that manages the health and things such as infection rate and a few other things. But for now, we will just make it a property of the character manager, because we have not got an inventory system, and we'll set health to 100 by default. So now let's get rid of the update function. We don't need that yet, but we do need a public function, the void return type, called take damage, and that function needs to take a float, which is the amount of damage we wish to take off of the health. So what we'll do is we'll say health equals, and then we just take the maximum of health minus amount and 0. So if, just in case amount was larger than health, we wouldn't want to end up with a negative health value. So if we do end up with a negative health value, 0 will be chosen instead. So now we know what the health should be. What we want to do now is we want to contact our camera blood screen effect, and we wish to basically set the minimum blood amount to what is essentially our health, or the inverse of our health in this particular case. So let's check we've actually got a reference to the camera blood effect script, just in case we forgot to hook it up. So what we'll do is we'll say camera blood effect .min blood amount equals 1 minus health over 100. Now remember, health is in the 0 to 100 range, so we need to divide it by 100 to get it into the 0 to 1 range. But we want our min blood amount to work differently to our health. So when our health is 100%, blood should be 0, and when our health is 0, blood should be 1. So that's why we do 1 minus health. Actually, I think what I'll do is, rather than just have the min blood amount correspond directly to our health, because remember, this is just for visual effect, I don't want a situation where when our health is really low, min blood amount could be like 0.9, and then if a zombie comes and attacks us, there's actually nowhere to go with that to make more blood appear on the screen. So I think I'll always make the blood that gets left on the screen be kind of like about a third of what our health actually is. Okay, so it always drops down to sort of a third. So I'll wrap that value in there, and then I will divide it by 3. Okay. Then I think what I'll do is I'll set the camera blood effects blood amount to our minimum blood amount plus, I don't know, like 0.3. So it's almost like in the normal case where we're not maxing out our health. There's always about a third after we've been damaged that the health is going to fall down to the min blood amount. But I probably need to make sure that I wrap that in a mathf.min so we don't allow blood amount to ever be more than 1. Okay, let's save that off. See if we've got any errors. Okay, let's press play on this puppy and see how she handles. Come on, come to dada. Okay, well, we can see it's working, but it's doing hardly any damage. Let me just unmaximize the screen. You can see, look, she's hit me about 5 times and I've still got 97% of my health left. So clearly this is not the right values of damage that our fists of our zombies should be doing to our player. So I think what I'm going to do, because it makes it easier to understand the values, is I'm going to make these values, instead of just making them some fraction that gets immediately reduced from the player's health, I'm going to make them per second values. If we set this to 50 for the left hand, what we're saying is if the zombie's left hand collider was in continuous contact with the player's collider for a whole second, it would take 50% of the player's health away. Now, that sounds quite strong, doesn't it? But in reality, because the animations that have the zombie lunging and punching are very, very quick, the hand is only really going to be in contact with the player's collider for a fraction of a second. So we want these values to be quite high. So as they intersect, they do some significant damage. So I'm going to put both the left hand and the right hand damage amounts up to 50. The mouth trigger is a different beast, however, because the way that the biting animation happens, it's like the player grabs hold of you, and for the entire time, the zombie's mouth collider is going straight down into the player's collider. So there's a very good chance that the mouth collider is going to be in contact with the player's collider for several seconds. And the other thing as well is I don't really want the impact of a mouth bite to be too sudden. I don't want to see lots of blood splat on the screen, because it wants to be more of a slow burn, because in the game, when the player's being bitten, we don't want him to notice straight away. And if he doesn't notice quick enough, that's when he's actually going to get infected. Okay, I know that's not exactly how zombie bites work, but it's a game, folks. What can you do? So I think we'll set the damage amount for the mouth trigger to maybe something quite small, like 10. Maybe even 5. I'm going to go down to 5. Now, I know for a fact that we've got a bit of a problem here, because I made a decision a few lessons ago when setting up our motion fields. And if I open up attack 2, which is our mouth bite animation, you can see that if we open up the curves for it, we actually created 3 separate curves for our biting animation. One for the mouth and one for the left hand and the right hand. And that's because it looks like the left hand and the right hand grab you as well. However, after testing this, it really doesn't work well, because when we're right in the middle of this animation for quite a period of time, it's just too aggressive. The left hand and the right hand are doing their body damage as well, and you just go from like 100 down to 0 very, very quickly. So what I'm actually going to do, guys, is I'm going to remove the left hand and the right hand curves from the biting animation, and I'm just going to let the mouth do the damage. Okay, and let me apply that. Oh, and of course the other thing is, because I've made the amounts now that we specify on these damage triggers per second values, I need to make sure that they're handled as per second values in the take damage function as well. So I'm going to need to multiply amount by time.delta time, like so. And of course, because the take damage function is called by the onStay trigger functions of the zombies trigger scripts, it means that it's actually being called in the physics step, which means time.delta time here will actually equate to fixed delta time, or 0.02, a 50th of a second. So if I save that off now, I'm kind of hoping we're going to be pretty close to what we wanted. That's the dream. Okay, come get me, sucker. Oh yeah, like that. That's good. Oh yeah, and I like the way it dissipates as we walk away from the zombie. I like that a lot. So she gives me a smack, it goes red. And every time she hits me, you can see the blood goes away a little less each time a little bit more remains. Oh, that was a headbutt. Okay, what I want to do really is I'm really happy with how the normal attacks are happening, but what I'm not happy about is I'm not really getting a chance to test if the value I've set up for the mouth trigger is correct. So I'm going to go into the animator and I'm going to just alter the transition into our biting animation. And at the moment, you'll remember that we generate a value in the state machine between 0 and 100, and we use that to choose the likelihood of each animation being chosen. So at the moment it says this will be chosen if that random number is greater than 20 and less than 36. I'm going to say less than 936, which will always be the case, obviously. So we should now see the mouth animation be the most likely animation. We had to see what the kind of damage is of that. She still gave me a slap first, didn't she? Yeah, I like that. Obviously the actual blood effect looks crap, you know, the particle system, but we'll do something better with that later on. It's probably a bit too mild, isn't it? No, I think I'm going to go, I'll tell you what, it is a little bit mild, so I'm going to go to the mouth trigger. I'm going to put that up to 10. I'll try that one more time. I want to see what it looks like from scratch. Oh, there you go, give me a bite. Oh, she's... What's going on here? She keeps doing the same attack. Bite me. Bite me. There you go. Yeah, I think that's about right. It's not too violent, so if she was attacking you from behind, you might not realise until it was too late when you start to see the blood accumulate on the screen that you've been infected. Works well, doesn't it? I like the blood effect. Okay, well, I think that's it. I think we're done. So thanks for listening, guys. In the next lesson, not quite sure, what will we be doing in the next lesson? Probably we'll start to implement the system that applies damage to the zombies. That will involve us also being able to apply damage to the zombies, which we can't currently do because we haven't got any weapons and we haven't got any FPS arms in the game yet. So what we'll do is we'll just mock it up in the next lesson. We'll put a little crosshair in the center of the screen and our character manager will listen for the mouse button being pressed, and when it does, it will cast a ray through that little crosshair and we'll see if we've hit a zombie. And in order to have the zombie react properly, we're also going to want to have the different body parts of the zombie with colliders on as well, which is also part of the process for getting it ready for ragdolling. So depending on how quickly it goes in the next lesson, we may have our zombie all ragdolled up and ready for some ragdoll physics, but we'll see how it goes. Thanks for listening, guys. I'll see you next time. Bye bye now.